Hi, I'm Taylor Terry and I will be discussing water activity. Water activity is an indicator of available water. The water activity of a food is not the same thing as its moisture content and is not a direct measurement of the amount of free or bound water. Water activity represents the ratio of the water vapor pressure of the food to the water vapor pressure of pure water under the same conditions. The water activity of a food in equilibrium with its surroundings is also defined as the equilibrium relative humidity of the surrounding atmosphere, which equals the percent of relative humidity divided by 100. The water activity scale extends from 0, which is bone dry, to 1, which is pure water. Most foods have a water activity level in the range of 0.2 for very dry foods to 0.9 for very moist fresh foods. 0.9 and greater is considered to be high water activity, while 0.6 and lower is considered to be of low water activity. At an water activity lower than 0.6, there is no microbial growth proliferation. Fresh fruits, meats, and milk have an water activity approximately of 0.95. Pasta noodles have an water activity around 0.5, and crackers have an water activity approximately of 0.3. With foods that have a low water activity, the tightly bound water has no tendency to escape from the food as a vapor and therefore exerts no partial pressure. It also has an effective water activity of 0. The amount of water binding is therefore indicated by the water activity. Water will move from a high to a low water activity region if a path is available for it. The water sorption isotherm is a relation between equilibrium moisture content of the material and water activity at a given temperature. Such relationships are the key to understanding the water sorption properties of food being of particular value when selecting a suitable package material and predicting the stability and moisture changes during storage. The relation of water activity and moisture is not linear. It does not depend on temperature and depends on the type of food. Since water activity is temperature dependent, it has a significant effect on sorption isotherms. Also, when a food is subjected to an upward temperature shift at any constant moisture content, water activity increases with increasing temperature. The relationship of water activity and moisture is not linear but is sigmoidal. The curve is called sorption isotherm. Most foods are sigmoidal, particularly if they have significant polymeric components. There are also adsorption and desorption curves. The distinct differences between the desorption and adsorption isotherm is defined by sorption hysteresis. Adsorption is always lower than desorption in cellular foods such as apples. The two curves are almost equal in non-cellular homogeneous foods such as cream cheese. Equilibrium of the two products with different moisture content and different water activities is based on water activity rather than moisture content. There are 3 zones of isotherms. Zone 3 is bulk water. It is effectively a dilute solution and is easily removed with minimum impact on food stability. Zone 2 is loose water, loosely bound water, and it is the additional layers to bound zone 1 water. Zone 1 is tightly bound water, and it is an exceptionally hard part to remove, and it needs very intense drying conditions in order to remove it. It is essentially the monolayer water. An individual water molecule will rapidly and continuously exchange between the three layers. The boundary between layers 1 and 2 is the critical moisture content that must be achieved for maximum stability. Water activity has the most useful application in predicting the microbial growth and reaction rates. For a food to have a useful shelf life without relying on refrigerated storage, and is necessary to control the level of water activity. At a point 2 water activity, non-enzymatic reactions and browning, non-enzymatic reaction browning and hydrolytic reactions occur. At around point 3, enzyme activity occurs, and at about point 7, there is mold and yeast growth, and at point 8, there is bacterial growth, and at point 9, there is a risk for pathogens. In conclusion, water activity and food deterioration. Stop here.